Hi, Tom English again, and I want to continue the lesson on triangles. And in this lesson we want to talk about similar triangles versus congruent triangles. First of all, similar triangles are basically the same shape, which says all their angles are the same, but the sizes of the angle or the triangles are different. And that gives us a way of finding the ratio of all the sides. For instance, in this particular triangle, we have a triangle that's 2, 3, 4. We say the angles are the same, so we know the shape of the triangle is the same, and therefore that says that the ratio of the sides, the corresponding sides, are going to be equal. So the way to find the missing sides is to set up the ratio with that we do know. In this case, we have the smallest side of both triangles. So we say 2 of the first triangle is to its corresponding side. 2 is to 4. In other words, this second triangle, that side is twice as big. Well, if they're similar triangles then the ratio is going to be the same for all the sides. In other words, the other 2 sides are also going to be twice as big. The way we solve this is to set up the ratio 2 is to 4 as 4 is to x. And hopefully you remember from your algebra, how do we solve ratio problems? We cross multiply, don't we? So this becomes 2x is equal to 4 times 4 is 16, divide by 2, and in this case x is equal to 8. Excuse me. We can find the other side by, in this case it would be the same ratio, 2 is to 4 as 3 is to y. Again, when we cross multiply, we get 2y is equal to 12, then y must be equal to 6. Okay, fairly simple, given that the triangles are similar. All you need is one of the sides to give you that ratio, and then you can figure out the others. Now, congruent triangles mean that they're exactly the same. The angles are equal and the sides are equal. And what we need to do is, when we prove triangles congruent, then we can fill in all the gaps as far as missing parts. In other words, if I know the side, corresponding side of 1, and I know the congruent, then that gives me the value of the unknown side. But there's a number of ways of proving triangles congruent. First of all, if the all three sides are the same, then the angles are bound to be the same, and therefore they're congruent. So if we think of side, 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 if we can prove all 3 sides the same or equal to their corresponding sides, then we can say that triangles are congruent. Also, if we can show 2 sides and the included angle, called side angle side, or SAS, if you can show those are equal, then you can say the triangles are congruent, and therefore other corresponding parts are also equal. Also, 2 angles and a side. If you think about it, if you got 2 angles, then the third angles have to be equal as well. And all you need is one side equal to its corresponding side in the second triangle, then that means the other sides also have to be equal to the corresponding side. Angle side angle is just another way of saying the angle side, because it doesn't really matter where the side is, does it? And this is saying that the side between the 2 angles, but if you know 2 of the angles, you also know the third one, so that side can fit in anywhere. And then lastly, if we have right triangles, we only need to prove the hypotenuse and a leg. And that's because if you look at a right triangle, you've got that right angle in there, and once you know the hypotenuse and one of the legs, everything else fits in place. So if it's a right triangle, all you need to do is prove the hypotenuse and the leg of one equal to the hypotenuse and leg of the other. I've drawn a few triangles here, and I'd like to use this to show how we would prove them congruent. I'm not going to get into proofs. That's a much longer lesson than I think you want to hear from me. The other thing is that if you get an idea of how to solve these, the proofs will kind of take care of themselves. Okay, let's look at these first two triangles, ABC and DEF. Often what happens is they'll give us, maybe they tell us that angle A is equal to angle D. Angle A equal to angle D. And they'll tell us that angle E and angle B are equal. Angle B and angle E. Okay? Now, think about what else do we need to know in order to be able to prove them congruent. Well, here we say if we have two of the angles in any one of the sides, we'd be able to prove. Is it any one of the sides? Yes. Angle, angle, side. So if they happen to tell us that AC was equal to DF, angle, or not angle, but side AC is equal to side DF, okay, then we can say these triangles are congruent by angle, angle, side, and once we know that, then that tells us, okay, AD, or AB rather, is equal to DE, and also CB is equal to EF. We have to do 3 there, okay? But the idea is that you have to pull in, show the equals here, either 3 sides, 2 sides included angle, the 2 angles in a side, and once you've proven that, then you can prove everything else. Let's take an example here. Let's say they tell us that we have JK is equal to MN. And then they tell us that KL is equal to PN. We've got 2 sides. What else do we need to know in order to prove these triangles congruent? Well, if they told us the third sides were equal, we'd have 1 by side, side, side. If they tell us, let's say for instance, angle P and angle L are equal, does that make them congruent? We don't have a side-side angle, do we? We have a side angle side, so it has to be the angle between the sides. So that doesn't help us at all. If they gave us that third angle, or the angle that we really need is what? Between the 2 sides. So we need angle K is equal to angle N, then we would have those by side angle side. I drew this one where it shares a side because often this is what confuses kids. They might tell us that BC is equal to AD and AB is equal to DC. And that's all they tell us. So we're looking to say, okay, we need to know this angle. No, they don't give us that. Any of the other angles won't. Well, how can we prove these congruent? The obvious answer doesn't always jump out at you, but in this case, this side AC is in both triangles, and that's called an identity. So what you would do is say AC is equal to AC, and the reason for it is identity, which says it's the same thing, isn't it? Identity. And with that, then you can say, okay, then triangle ABC is congruent to triangle ACD, and then all the other parts are equal as well. So hopefully that gives you just an idea of how we can prove triangles congruent. If you're going to get into a lot of proofs, you need to dwell into it more deeply. And I'll have some references on my site of other websites and other tools that you may want to look into. Thank you.